Ethereum is a programmable blockchain. Rather than give users a set of predefined operations, an example, Bitcoin transactions, Ethereum allows users to create their own operations of any complexity they wish. In this way, it serves as a platform for many different types of decentralized blockchain applications, including but not limited to cryptocurrencies. Ethereum in the narrow sense refers to a suite of protocols that define a platform for decentralized application. At the heart of it, it is the Ethereum virtual machine, the EVM, which can execute code of arbitrary algorithm complexity. In computer science terms, Ethereum is Turing complete, but developers can create applications that run on the EVM using a friendly programming language modeled on existing languages like JavaScript and Python. But like any blockchain, Ethereum also includes a peer-to-peer network protocol, and the Ethereum blockchain database is maintained and updated by many nodes connected to the network. Each and every node of the network runs the EVM and executes the same instruction. For this reason, Ethereum is sometimes described evocatively as a world computer. And this massive parallel of computing across the entire Ethereum network is not done to make computation more efficient. In fact, this process makes computation on Ethereum far slower and more expensive than on traditional computer. Rather, every Ethereum node runs the EVM in order to maintain consensus across the platform, across the blockchain. But decentralized consensus gives Ethereum extreme levels of fault tolerance, ensures zero downtime, and makes data stored on the blockchain forever unchangeable and censorship resistant. So the Ethereum platform itself is featureless or value agnostic, similar to a programming languages, and it is up to entrepreneurs and developers to decide what it should be used for. However, it is clear that certain application types benefit more than others from Ethereum capabilities. Specifically, Ethereum is suited for applications that automates direct interaction between peers and facilitate coordinated groups action across a network. For example, I will say applications for coordinating peer-to-peer marketplaces or the automation of complex financial contracts. Bitcoins allows for individuals to exchange cash without involving any middleman like financial institutions, banks, or government. But Ethereum's impact may be more far-reaching. In theory, financial interactions or exchanges of any complexity could be carried out automatically and reliably using code running on Ethereum. And beyond financial applications, any environment where trust, security, and permanence are important. For instance, asset registries, voting, governance, and the Internet of Things. All of that could be massively impacted by the Ethereum platform. So how does Ethereum work? Well, Ethereum incorporates many features and technologies that will be familiar to users of Bitcoin, while also introducing many modifications and innovations of its own. Whereas the Bitcoin blockchain was purely a list of transactions, Ethereum basic unit is the account. So the Ethereum blockchain tracks the state of every account and all state transitions on the Ethereum blockchain and transfer of value and information between accounts. And there are two types of accounts. Externally owned accounts, the EOAs, which are controlled by private keys, and the contract account, which are controlled by their contract code and can only be activated by an EOA. But for most users, the basic difference between these is that human users control EOAs because they can control the private keys, which give control over EOA. But contract accounts, on the other hand, are governed by their internal code. If they are controlled by a human user, it is because they are programmed to be controlled by an EOA and with a certain address, which in turn are controlled by whoever holds the private key. The private keys that control the EOA. And the popular term smart contracts refers to code in a contract account, programs that execute when a transaction is sent to that account. And users can create new contracts by developing code to the blockchain. Now let's get into hashing, which is the next lesson.